This is a Tom and Jerry question. Now, Jerry is sleeping on the floor in the middle of a 3-meter wide room when Tom enters the room with a speed of 1.5 meters per second. Now, as Tom enters, Jerry immediately accelerates at 0.85 meters per second squared towards the open window on the opposite side of the room. Tom gets distracted by a human and starts slowing down at 0.1 meters per second square as soon as it enters the room. Can Tom catch Jerry?
Where'd everybody go?
So first of all, let me draw a picture here. So let's say if I have a room here, and there's a window here. Oh gosh, that doesn't look like a good window. I am not sure how to do it. So let's say this is the window. And this room is 3 meters wide. And Jerry is sitting right here. And where's Tom? Tom is actually outside and is trying to enter the room. So here's Tom. Now the acceleration of Tom, sorry, it says the Jerry immediately accelerates at 0.85 meters per second, but once Tom enters, has a speed of 1.5 meters per second, and then Jerry starts accelerating here at 0.85 meters per second squared. Now, what I'm going to write, I'm going to actually write my givens. So for Tom here, my initial velocity is 1.5 meters per second. My acceleration, I'm going to be slowing down. So minus 1.5 minus 0.1 meters per second squared. So what we want to know if the Tom catches Jerry at this point, which is at the window, which is going to cause Tom to travel 3 meters. And now for Jerry, I'm going to have my initial velocity at rest, so 0 meters per second, my acceleration at 0.85 meters per second squared, and the distance that I'm going to travel here for Jerry is half of the room because it's in the middle of the room, so 3 divided by 2, which is 1.5 meters. Let's say if it takes Jerry 5 seconds to reach the window, and it takes Tom 6 seconds to reach the window. Obviously, by that time, Jerry would have jumped out of the window, and Tom would not be able to catch him. But let's say if Tom were to reach the window at 4 seconds, therefore he would be able to catch Jerry. So what I need to find out is what T1 and T2 is, compare them. After, I will understand if Tom will be able to catch Jerry or not. So looking at Tom, I have the initial velocity, I have the acceleration, and I also have the distance. What I'm missing is time. So if I'm looking for time, what equation do you think I should use in order to be able to fit everything together? Now, looking at this equation, this one actually involves all the values that I'm looking for, which is delta D, A, VI, and delta T. So I'm just going to write the equation down here. Delta D1 equals V1 delta T plus half of A delta T squared. Now I'm going to plug everything in. So I have 3 equals, for my V1, I have 1.5. For my delta T, which is unknown, I have half. Acceleration is 0.1, and it's a negative number. And my T squared is going to be here. Okay, this looks like a quadratic equation. I'm just going to rearrange this first. So I have 3 equals 1.5t, half times 0.1, I have minus 0.05 t squared. Now let's put everything on one side. I want to have this as a positive value because I want to organize it a little bit better. So I have 0.05 t squared moved to the other side. I will have 1.5t move to the other side as well. So the sign changes. And what I'm going to do after, I'm going to keep 3 on the same side and put everything equals to 0. Now, I hope you remember how to solve a quadratic equation. I know I do. So I'm going to specify these values. So I have a as 0.05, b as negative 1.5, and c as 3. Remember my quadratic formula, so my t1 and t2 should equal to negative b plus minus b squared minus 4ac over 2a. Now go ahead and pause the video, plug everything in, and tell me what you get for t. Okay, welcome back. Now, your answers should be 27.8 seconds and also 2.2 seconds. So if you found this, skip this part of the video. If you have not, please make sure you go through with me to get the answer. So I have T1 and T2 equals minus B, which is positive 1.5 because I have a negative 1.5 here. If I multiply a negative sign by negative 1.5, I'll have a positive 1.5 plus minus, again, negative 1.5 to the power of 2 minus 4 times A. My A is 0.05 and C is 3. All over 2 times A, which is 0.05. Putting that into my equation, actually let's do it on a different page. So let's do it over here. Having that, I will have 1.5 plus minus 1.5 times to the power of 2. I will have 2.25 minus 4 times 0.05 times 3 will be 0.6. And 2 times 0.05, it will just be 0.1. Now, for my final step, I will write 1.5 plus minus. What I want to find out is what this square root means. So I will have 2.25 minus 0.6, which is 1.65. Square root of that is just going to be 1.28 over 0.1. Now I will have two answers. One, which is my T1, 1.5 plus 1.28 over 0.1. Or for my second answer, which I have 1.5 minus 1.28 over 0.1. Now I'm going to do it for the first one. So 0.128, 1.5 plus 1.28, 2.78 divided by 0.1. It would give me 27.8 seconds. For my second part, I will have 1.5 minus 1.28, which is 0.22, divided by 0.1. It will give me 2.2 seconds. Now I have two times that are both positive that I can actually look at. So there are two different times that Tom can travel that 3 meters. Now what I'm going to do is that I'm going to actually go back and solve for Jerry and compare it to what I find for Jerry. Now let's take a look and see what I can use to help Jerry. Now going back to my initial equation here, Jerry's initial velocity is known, acceleration is known, and also d2 is known. So what equation do you think we should use in order to find the time that it takes for Jerry to travel half of the room? I would propose that we can use the same equation here because everything here, including delta D, V1, and A is known. Now the only thing that is unknown is delta T. I'm going to plug all of the values, which is including delta D, my V1, and A is known. The only thing I don't know is delta T here. Now let's plug in everything and see how it works. So delta D would be 1.5 meters, remember, because Jerry was in the middle of the room. And then the initial velocity was 0 plus half of the Jerry's acceleration, which was 0.85 meters per second squared. And then I have my t squared. Now to simplify this, I will have 1.5 equals 0.85 divided by 2. 0.85 divided by 2 is 0.425 t squared. Now, in order to find t squared, I'm going to have to divide both sides by 0.425 to get rid of the coefficient. Now, I will have t squared equals 1.5 divided by 0.425, which is 3.53. And the square root of that would just give me t, which is 1.89 seconds. Now it takes Jerry to reach the window 1.89 seconds, and it takes Tommy. Which one do you want to use? I obviously want to use this one because this one makes more sense. So I'm going to take 2.2 seconds, and since Jerry is only going to take 1.89 seconds, Jerry is actually going to run away, and Tom will not be able to catch him. So no, Tom won't catch Jerry. That's about it. Thank you for watching. If you have any questions, comment them down below. And please make sure you subscribe to our channel. Thank you very much.